Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of differential equations. And if I talk about the question which is given to us here from this topic, the question tells us that x is equal to x of y is a solution of the differential equation which is given to us as 2 times y plus 2 log of y plus 2 to the base e dx plus x plus 4 minus 2 times log of y plus 2 to the base e, the whole thing multiplied with dy is equal to 0. So this is our entire differential equation given. We have been given y is greater than minus 1, and we have also been given that x multiplied with e raised to 4 minus 2 is equal to 1. So we have been asked at x e raised to 9 minus 2 is equal. So we have been given x of y is a solution of this entire differential equation. And at y equal to e raised to 4 minus 2, we have been given x equal to 1. We have been asked to find at y equal to e raised to 9 minus 2, what is the value of x. Just let's solve this differential equation. So what I'll do is I'll divide my entire differential equation by y plus 2 and dx. So if I differentiate my entire differential equation with y plus 2 into dx, I get log of y plus 2 to the base e, which is 2 times, because I am dividing by y plus 2 and dx, plus x plus 4 minus 2 log of y plus 2 to the base e dy by dx, and I am dividing it by y plus 2. That is equal to 0. So I get this entire thing. Now what I can do here is I can substitute this entire expression as, so put log of y plus 2 to the base e is equal to t. So what I get here is 1 upon y plus 2 into derivative of y plus 2, which is dy by dx. It is equal to dt by dx. So I'm differentiating with respect to x, so you get dy by dx and dt by dx here. So once I get that, I understand 1 upon y plus 2 dy by dx. I can just replace this with dt by dx, and log of y plus 2 to the base e I have always referred to as t. So I substitute that, and my differential equation terms to become 2t plus x plus 4 minus 2t into dy by dx upon y plus 2, which is dt by dx. That is equal to 0. So dt by dx basically becomes minus 2t upon, or I should write that as x plus 4 minus 2t here. Here you don't write anything, so you get minus 2t. Now, if with that, if I take it on the other side, I get dt by dx turning out to become minus 2t upon x plus 4 minus 2. So I get this entire form. So if I try to take this minus sign and contain it with this, I get dt by dx turning out to become 2t upon this becomes 2t minus x minus 4. So what I get here from this idea is, let's see, I don't need dt by dx, I need dx by dt, because I need to find my solution in terms of x now, right? Or in terms of y as a function. Because till now, whatever questions we have done on differential equations, you would always get y in terms of y of x. So you will always get y in terms of a solution of x. But here you have to find the different solution. You have to find the solution of differential equation in terms of the function of y. So let's try to find that. So for that, if I convert this idea dt by dx as dx by dt, I'll just invert it, so you get dx by dt turning out of it 2t minus x minus 4 upon 2. So you get this entire thing here as, if I take it on the other side, you get dx dx by dt equal to 1 minus x by 2t minus 4 by 2. So you have this x by 2t, if I take it on the other side, becomes dx by dt plus x by 2t. It is equal to 2t minus 4 upon 2. Now once you have this entire expression, if I just confirm and compare it with dy by dx plus py equal to q. Here instead of y you have x and instead of x you have t. So we used to have integrating factor for this expansion as e raised to integral p dx, and we had q into if, it's equal to integral of, or we had y into if, integral of q into if into dx plus c. So this was our entire solution of the differential equation for this form. But if I go according to this idea now, we have here comparison. So instead of y, we are putting x, and instead of x, we are putting t in this. So your integrating factor becomes if becomes e raised to integral p dt. You are integrating it with respect to t, because here instead of x, you are putting t. And your solution becomes y into if. So y is nothing but x in this case into if. It's integral of q if. Instead of x, you are putting again t plus. So you get this entire thing. Now let's just solve this. So integrating factor p, we already have that with us. Let's find that. P here in this case is 1 by 2t, and q here we have it as 2t minus 4 by 2. So let's see. I find integrating factor as e raised to integral 1 upon 2t dt. So you get e raised to half integral of dt by t, that is e raised to integral half into integral of dt by t is log of t. That gives you e raised to log of t raised to half. So e raised to log of f of x, if I see, it is given as f of x. So I can just write that as t raised to half. So you get integrating factor as t raised to half. So your solution becomes x into t raised to half, because you had x into if. It is integral of q. So integral of q here is 2t minus 4 upon 2t multiplied with t raised to half dt plus. So if I solve this further, I get x t raised to half. Integral of this becomes, if I separate this denominator 2t by 2t, so 1. So integral of t raised to half dt minus 4 upon 2 t raised to half upon t, so t raised to minus half dt plus. So you get this understanding x t raised to half. This becomes t raised to 3 by 2 upon 3 by 2 minus, here you get this as 4 by 2, which is 2. T raised to minus half, if I integrate, I get again t raised to half upon half plus c, that is your constant. So if we try to simplify this expression, let's see what I get. So I get x t raised to half is equal to 2 by 3 t raised to 3 by 2 minus, you have 2 and 2, so 2 into 2 becomes 4 t raised to half plus c. So if I divide throughout by t raised to half, so I'll get 3 from t on the left hand side. So if I divide it 2 by 3, 3 raised to 3 by 2 and dividing by half, so that gives you minus half, minus 4 t raised to half upon t raised to half plus c upon t raised to half. If I take that in the numerator, becomes t raised to minus half. So this gets cancelled. You are left with x equal to 2 by 3 t raised to 2 by 2, which is t, minus 4 plus c t raised to minus half. So you get the solution of this differential form. Now once I have the solution of this form, I'll resubstitute t as log of y plus 2 to the base e. So x becomes 2 by 3 log of y plus 2 to the base e minus 4 plus ct. So log of y plus 2 to the base e raised to minus half. So you get this entire expression. Now once you have the entire equation in terms of x, y and c, we'll use the condition that was given to us, that is x equal to 1 when y is e raised to 4 minus 2. So once I have that, I'll resubstitute and I'll get c here. So I'll substitute x as 1, 2 by 3 log of e raised to 4 minus 2 plus 2. So you get e raised to 4 to the base e minus 4 plus c. Here you get log of e raised to 4 minus 2 plus 2 to the base e. So log of e raised to 4 to the base e raised to minus 1. So you get this entire expression as 1 equal to 2 by 3. 4 log e to the base e is 1 minus 4 plus c. Here you get 4 raised to minus half, that is 1 upon 4 raised to half, which is 1 upon 2. So you get the entire expression to become 1 is equal to 2 by 3 into 4, that is 8 by 3 minus 4 plus c upon square root of 4, that is 2. So you get this entire expression as 1 plus 4 minus 8 by 3 is c by 2. So you get this as 5 minus 8 by 3, 15 minus 8, 7 by 3 into 2 is equal to c. So from this expression, I get the value of c as 14 by 3. Once I get the value of c as 14 by 3, now let's just put that value of c in my solution of differential equation as 14 by 3, and let's find the value of x when you have y as e raised to 9 minus 2. So that was asked to us. Let's plot that and find that out. So we have been asked to find the value of x when y is e raised to 9 minus 2. And c, we already know it is 14 by 3. So if I put x, y and c, I'll get the value of x from this solution of the differential equation. So x basically becomes 2 by 3 log of y plus 2. So log of y, we know e raised to 9 minus 2. E raised to 9 minus 2 and plus 2. So minus 2 and plus 2 cancels. E raised to 9 to the base e minus 4 plus c log of e raised to 9 minus 2 plus 2 to the base e. So log of e raised to 9 to the base e raised to minus half. So you get x as c already also was given to us 14 by 3. So I'll substitute that. So you get x as 2 by 3 log of e raised to 9 to the base e. 9 if I take it ahead becomes 9 minus 4 plus 14 by 3. Here you get 9 raised to minus half. So 1 upon 9 raised to half, which is square root of 9, 1 by 3. So you get x as 18 by 3 minus 4 plus 14 by 9. So if I solve this further, I'll multiply throughout by 3. So you get 54 by 3 plus 14, so 68 by 9 minus 4. 68 minus 36 by 3, that is 32 by, not 3, it is 9. So actually we have to make a mistake. So let's put 9 here. 68 minus 36 by 9, so 32 by 9. So you get the value of x as 32 by 9. If you see the option that matches here with the question, so if I see the options, so if I talk about the options that are given to us here, the options are 4 by 9, 32 by 9. Then the other option that was given to us is 10 by 3. And the last option given to us was 3. So if you see the option that matches here with the question is option B. I hope you have understood how to solve this type of questions which deals with the ideas of differential equations. So our entire solution in this differential equation was just the opposite, that we were finding our entire solution in terms of y here instead of x in the previous questions which we have done. So we just substituted here log of y plus 2 to the base e as t, and we converted our entire differential equation in the form of dx by dt, and then we solved it further using this general form dy by dx plus dy equal to q. We found the integrating factor. We used the solution of differential equation in this form. Once we got the solution, we put x as 1 and y as e raised to 4 minus 2 to find constant, that is c. We got c as 14 by 3. Once we got the value of c, we just put y as e raised to 9 minus 2 and found the value of x. That matches with option B. So B is the correct answer for the question given to us. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of 11th, 12th and JEE mains. So stay tuned for more videos to roll out. Also, do like, share and subscribe to my channel. You share these videos with your friends also who are involved in the preparation of questions on JEE. So they can also take the benefit from these questions which we are solving on a daily basis. Thank you.